a little more. We'll go from the tree root scale to the global scale. That's where I've really been focusing for the last 3 or 4 years. And I'll talk today about futures for Australian land use and ecosystem services. So if there's anyone left in the crowd who doesn't know what they are, they're just the benefits that people get from the natural environment. So the context here is that we need to produce more from less land. In an agricultural sense, we need to increase agricultural production. There's increased demand from more and more people on a global scale. Latest estimates around 9.6 billion by 2050. Each one of these mouths are eating more, consuming more, and there's limited opportunities for increased production. There's not a lot of areas globally that are able to be expanded in a big way. There's some opportunity, but not a lot. There's a lot of competition for our existing agricultural land from other land uses like mining, from urban areas, new incentives to store carbon on our lands, and also conservation and ecosystem services provision. So we all expect our agricultural lands to be kept in good shape. And there's a backdrop of challenges about meeting these global demands. And they're things like ongoing land degradation, the need to adapt to changing climates, and also declining rates in productivity growth. And you can see those graphs there, that's productivity in the grains industry over the last 20 or 30 years. And you can see how it's gone from a traditional roughly 2% increase to pretty much no increase over the past 15 years. So these are very, very concerning to people in Canberra about why those rates of declining productivity growth have occurred. This is all in the context, this work that I'll present on futures for land use is in the context of a much broader study that we've just completed and published, and that's our front page of Nature there. That's our graphic on the Australian National Outlook. And the outlook says it's all about growth and whether we can decouple or separate economic growth from environmental impacts. And it says we can, but we need smart policy and we need to implement it now. What I'll talk about is the land use component of that. It has much broader components across the whole economy, all sectors of the economy. It looks at multiple issues of consumption, efficiency, productivity and conservation, multiple scales from global right down to the local scale, multiple sectors of the economy, as I said, and we had a very large team here within CSIRO addressing this, from people looking at economics at the local scale, at the global scale, hydrologists, ecologists, mathematicians, sociologists and so on. So it's very interdisciplinary work, and I'll talk about just one component of it. That component of land use required that we develop a new modelling capability, and that model is called LUTO, the Land Use Trade-offs Model. And it's a national land use model for Australia. It covers the agricultural areas, the cleared agricultural areas, intensive land. And it's a bottom-up integrated model of the environment and the economy. It's detailed, it's about 1.1 square kilometre grid, and it occurs on an annual time step. So we model the drivers of land use change and the influence of those drivers on changing what people do on their land, and also then the impacts of those changes. So it lets us project potential land use responses to different policies or different global scenarios or policy scenarios. It quantifies the impact on sustainability not only of the economic conditions but also the environmental conditions over space and time. And it lets us test a what-if scenario of different policy options. So what if we undertake different energy options like Courtney's just presented? What if we undertake different conservation or land use regulations, different productivity rates in agriculture and so on? Let's look at the impacts on land use, on the economic and environmental bottom lines. This is how the model hangs together. So there's a lot of different boxes flowing in there into our little red land use allocation algorithm here. There's a whole range of modelling that goes into it, from environmental modelling of climate and soil to fire and drought, how trees use water, how trees store carbon, how crops produce yields, biodiversity, climate change and so on. There's also a range of different economic and social models of land use, of prices and costs of production, how farmers adopt to different price signals and change land use. There's a range of outputs, some of which I'll show today, and a whole heap of different scenario combinations that we analysed. So I won't go into that in any detail, but happy to talk about that after. And the most important thing is some global change scenarios here, just listed. I'll go into these a bit more. A low climate change, low population, two medium climate change, the M3 and M2, and then there's the high climate change, high population scenario. Important thing here, just describing these global outlooks. So this is a global context in which our land use change model works and the conditions to which farmers respond in changing land use. So the important thing here, apart from global action on population and climate change, is our price signal. So to achieve a low climate change future, you need a high carbon price, and these are the prices that our global economic models, the integrated assessment models, tell us that will be required by 2050 to achieve a 2-degree warming by 2100. So these are getting pretty substantial. So if you look at the 2050 price, L1 is $200 per tonne, about $120 for M3, about 60 for M2, and about 0 for H3, because you've got no carbon price, you've got high climate change. The model starts off with a land use map in 2013. This is the area of agricultural land that it looks at. These are the different types of agriculture, so it's about 24 types of agriculture. And it says, all right, well, what if we had price incentives and policy incentives to change land use to this range of new options? What if farmers had new options to which they could make money and have an environmental impact? So carbon plantings are eucalyptus monocultures that grow fast and store carbon fast. Environmental plantings are local diverse species. And then there's a range of biofuels and bioenergy. So the model is what's called a partial equilibrium model, where we start off with agriculture, new land uses become competitive because there's price signals for carbon and energy and so on. And what happens, that purple line there, the supply curve, new land uses outcompete agriculture, the supply curve moves up, and if the supply curve moves up, the prices of agriculture also move up. So land use gets competed for until no more land use change is possible. So it's an economic model. It also includes a range of different biodiversity rules and constraints and so on. Here's an example just of one of the output from a fairly central model. So here we've got the inputs of crop demand, livestock demand, carbon price and so on. Here's our climate change happening down here. Here's our output, so land use area, economic returns, and a range of different ecosystem services. And here we've got the map of what's happening in the background. So if you watch carefully, this should tick over year by year. You've got the year changing here, and we've got our drivers changing. And in the background, nothing's happening yet, but watch the map. Things start happening. Once you get the economic drivers, in particular the carbon price, starting to happen now. So you get a lot of sequestration up here in this beef country in southern Queensland, which makes about $50 a hectare from growing beef, but it also stores at a minimum 10 tonnes of CO2 a year, probably more like 20. And if that's by 2050 getting $200 a tonne, you do the maths. This is not just marginal increases in profitability. These are things that will transform land. These are 10 times, 20 times more money that you could make from doing something different to what you do now. That's a zoomed in area of around Tamworth, just so you can see the spatial resolution with topography underneath there. So it's a reasonably high resolution model for a national model. These are some of the mapped changes. So you can see the climate change scenarios across the top. These are just different biodiversity policies. And you can see the blue, depending on the carbon price essentially, the global outlook and different policy options, I guess all I can get across to you with this sort of time limitation is those maps look pretty different depending on the assumptions that you make. So the policy and the global circumstances that drive different land use responses are fundamentally impactful on what people do on their land. And of course, that makes an impact on their economic returns to Australian agricultural land and also the ecosystem services. So if we just look down across the columns, we can see in that where there is a signal for to store carbon, farmers make a lot more money. This is economic return. So we're making a lot more money, and a lot of that money is coming from new land uses. As we get through to a high climate change scenario, we're not making a hell of a lot more money than we are now. We can talk about biodiversity if we had more time or in questions. We can then look across these ecosystem service impacts across abatement, for example. So this is time from 2013 to 2050. This is annual emissions abatement, and this is cumulative. So you can see, depending on the carbon price and global outlook, emissions abatement, Australia's emissions abatement is about 550 to 600 megatons per year, and so that's pretty close to our entire emissions stored in Australia's agricultural lands under these economic and global circumstances. But it happens earlier, depending on the carbon price, so time is an issue. Biodiversity is very dependent on having a complementary national biodiversity policy, which taps into the carbon price but includes a payment for additional biodiversity services from land management. So it encourages environmental plantings in high priority areas. Water resource use is of course going to be an issue because we're replacing shallow-rooted crops with deep-rooted trees which use more water, and those sorts of water use across the nation are in the order, even for the medium climate change scenarios, of around the entire flow of the Murray-Darling Basin under natural conditions, with about 20,000 gigalitres per year. So of course we need to start managing that and targeting plantings and putting in things like cap and trade systems across our sensitive catchments to manage the impact of plantations. I won't worry about energy, but I'll then conclude. And just to summarise, we've looked at this integrated modelling of land use change and then the sustainability impacts from that across the environment and the economy. This capability is world class. We've got lots of publications I'll put up in the last slide, so you can go and have a look at some of those publications if you're interested in some of the details, or I can send them to you directly. We looked at intersecting global change scenarios with domestic policy scenarios and the real nuance and strong impact that both global change but also domestic policy makes on land use and ecosystem services. It's a continental scale but at high spatial and temporal resolution, and it can help us understand potential land use responses, the economic sustainability of our land, and also the provision of ecosystem services. And the policy sphere that this can contribute and inform is large, as some of those papers. The top one is just out, and that's pretty much a summary of the work we've done on land that I've just presented there. Thank you. Okay, thanks, Brett. Time for one or two quick questions. Yes.
That was really interesting. Thank you.
Thanks.
I'm just wondering if one of the inputs into Ruto is social values of the environment.
Well, yes, but as reflected in price signals for things like carbon, things like water, but
That's intrinsic.
less so. Biodiversity, we assume a certain price is put on biodiversity, but it's the opportunity cost of actually, doing what would actually make you the most money. There's nothing really around recreational values or spiritual values, educational values of natural areas, anything like that. But prices where we can put a more of a marketed value on the service is definitely in. Yeah.
Recognising the value of
Yeah.
I wondered if there was a way to nuance
Yeah, I mean, we'd look to, if we could price those sorts of things, you could then use that to inform a payment for ecosystem services. But the real trick is doing that work on pricing and then capturing the heterogeneity across the landscape. You know, how much is this actually worth?
Okay, one more question off the back.
To what extent are our policymakers at a state and federal level engaging with and utilising veto power?
It's a growing extent. It's just really been published. The Outlook was published in November, and the Luto stuff is just published now. We had a conversation piece come out 2 weeks ago. So we're talking with the state government about informing the carbon neutral Adelaide stuff. Victorian government are bringing in things around offsets and emissions in a similar way. In Commonwealth Department of Environment, Department of Ag are talking about natural capital and ecosystem services. So it's really the start of a much broader conversation. Climate Works were contributed our land use stuff to the COP21 in discussions in Paris. So there's bits and pieces, but we'd like it to have a much stronger role in informing policy. There's a lot in there, and I think now is the time to start those discussions about pulling out individual aspects of it, doing tailoring, new model runs for locally specific issues, new policy testing, new land uses, all sorts of locally specific different actions you could take or different things that are of interest at the local level.
Might have to leave it there, so if you can thank Brent and also all our